All right, we're back to factor two more trinomial expressions. So if we look here, we know this is a trinomial. It has 1, 2, 3 terms. We know it's written in the correct descending order. We also know there's nothing in common. All three terms do not have a C, and there's no number 1, -10, or 25 could all divide by. So there's no GCF. We know because the trinomial, our first gut is to put our two sets of parentheses, and we know we're doing backwards FOIL. So we start with the first term. What can multiply to C squared? Because the leading coefficient is 1, we know this is easy. There's only one option. It's C times C. After we go to the first, we go to the last. We look at the number 25. We list our options. 25 is 1 times 25. It's not even, so we can't use 2. It's not a multiple of 3. It's not a multiple of 4. It is a multiple of 5. 5 times 5. Okay? So we're okay with that. Those are our factors of 25. Now we're going to read. I want to multiply to 25, and I want to add to 10. Don't worry about the sign yet. Just look at the number. Will 1 and 25 add to 10? No. Will 5 and 5 add to 10? Yes. Now I want to add to a -5. So if I want to add, we know the signs have to be the same. We can only add terms that are alike. If I want to add to a negative, they both have to be negative. We talked about this. When you factor a trinomial and the two binomials are exactly alike, this is then called a perfect square trinomial. And therefore, we could write this answer a better way. Instead of in algebra writing C minus 5 times C minus 5, a better way is saying C minus 5 squared. Make sure you put the parentheses. If you write it like this, you're going to get marked wrong. That does not say C minus 5 squared. That just says 5 squared. You're saying the whole set of parentheses is listed twice. Okay? One more example. D squared plus 9D minus 12. All right, I have a trinomial. It's in the correct descending order. I know it should factor into two sets of parentheses. D squared is easy. The only thing in algebra that can multiply to D squared is D times D. After I'm done with the first term, I go to the last. Don't worry about the sign, just worry about the number, 12. What are my options for 12? 1 and 12, it's even. 2 and 6, 3 and 4, I know I'm done. All right, great. Read. What does it want you to do? It wants you to multiply to 12 and subtract to what's in the middle, which is 9. So let's go. 1 and 12, if I subtract, it gives me 11. That does not work. 2 and 6, if I subtract, it gives me 4. That doesn't work. 3 and 4, if I subtract, it gives me 1. That doesn't work. You have exhausted all your options. There are no more options here. Nothing can multiply to 12. There are no two numbers that multiply to 12 and also subtract to 9, which means we cannot finish this factoring process. If your expression does not factor, you call it prime, which means this is in lowest terms. We cannot rewrite it as multiplication. Don't sit here and try to think of what you could subtract to make 9. You could come up with many numbers that subtract to make 9. I could put 10 and 1 in here. But that's not going to work because 10 times 1 is still not 12. Remember, this set of numbers is doing both jobs. It's multiplying to the last, and it's either adding, subtracting to the middle. So that's why if you write all your options here, if you go through all of them and none of them work, it tells you your trinomial's prime. It does not factor. Okay, and that's something you got to get used to understanding. Not every algebra expression is going to factor. All right, I'll see you in the next video. We got more trinomials to look at.